Skill practice 1 asks us to compute the dot product and find the magnitude of a couple of vectors. If we have vector v that is given with the components a1 and b1, and vector w that's given with the components a2, b2, we find their dot product by taking a1 times a2 plus b1 times b2. This means that a1 would be -2, a2 would be -3, b1 would be 6, and b2 would be -1. Computing the dot product of vector v times vector w, we're going to take -2 times -3 plus 6 times -1. We then have 6 minus 6, which is 0. For part B, we're taking vector w times vector v, which we know by properties of dot products should be the same result. This means we're going to take -3 times -2 plus -1 times 6, which the commutative property of multiplication says is the same thing as what we did in A. We then have 6 minus 6 again, which is equal to 0. Part C, we're multiplying vector v times vector v, which we know by properties of dot products should be the magnitude squared. That's going to be -2 times -2 plus 6 times 6. And -2 times -2 is 4. 6 times 6 is 36. So we have 40. Part D is the magnitude of vector v. That should be the square root of c. But we find the magnitude by taking the square root of the a component squared plus the b component squared. That's equal to the square root of -2 squared plus 6 squared. And -2 times -2 is 4. 6 times 6 is 36. So that's equal to the square root of 4 plus 36, which is the square root of 40, which we can simplify because there's a perfect square of 4 inside. That's the same thing as the square root of 4 times the square root of 10, which is 2 root 10. Skill practice 2, we are asked to find the angle between these two vectors. We're going to use the fact that theta is equal to the inverse cosine of the dot product of vector v times vector w divided by the magnitude of vector v times the magnitude of vector w in order to find this angle. Let's compute the dot product first of vector v times vector w. Remember, we take the a components times each other plus the b components times each other. We then have that the dot product of vector v times vector w is equal to 5 times -5 plus -1 times 12. That's equal to -25 minus 12, or -37. Calculating the magnitude of vector v, we find the square root of a squared plus b squared. That's equal to the square root of 5 squared plus -1 squared. And 5 squared is going to be 25, and -1 squared is going to be 1. We then have the square root of 26. The magnitude of vector w is then equal to the square root of -5 squared plus 12 squared. That's equal to the square root of 25 plus 144, which is equal to the square root of 169, which is 13. We can now plug these values into the formula for theta. That's equal to the inverse cosine of the dot product, which is -37, divided by the magnitude of vector v, which was root 26, times the magnitude of vector w, which was 13. We can then calculate using our calculator in degrees mode that angle theta is equal to approximately 123.9 degrees. Skill practice 3 asks us to determine if vectors are orthogonal, and in order for vectors to be orthogonal, they need to form a right angle with each other, which means that their dot product is equal to 0. So vector v and vector w are orthogonal if and only if their dot product is equal to 0. Remember that the dot product is calculated by taking the a component's product plus the b component's product. The vectors are written where they're in the form vector v is equal to ai plus bj. Writing in this form, that would mean that a1 would be 4 and b1 would be 3, a2 would be 6, and b2 would be negative 10 using vectors v and vector w. For vectors s and t, a1 would be negative 2 and b1 would be 1, a2 would be 11 and b2 would be 12. Calculating the dot product of vector v times vector w, we have a1 times a2, which is 4 times 6, plus b1 times b2, which is 3 times negative 10. This is equal to 24 minus 30, or negative 6. Negative 6 is not 0. These are not orthogonal. The dot product in B gives us a1 times a2, which is negative 2 times 11, plus b1 times b2, which is 1 times 22. We then have negative 22 plus 22, which is equal to 0, so vector s and vector t are orthogonal.